Hello, this is Jack Jackson. In this video, we're going to talk a little bit about cost, revenue, and profit, and use calculus to analyze some things related to this. So, we see here the graph in blue and red of the cost and revenue functions, where they're functions of the quantity. So the Y values here, or output values, are dollars, amount of money that it cost, or the revenue. And the X values are the quantity of items made and then hopefully sold. Now, the first thing is, how do you know, well, first of all, what do cost and revenue mean? What do those words mean? Well, in both cases, you're taking the perspective of the producer or supplier. So the cost is what it costs them to make the item, okay, the manufacturer to make the item. Okay, it is not the cost of the consumer. Okay, so be sure you understand that. That's the cost of the manufacturer to make the item. Revenue, then, is the total money received from selling the items. Okay, and then profit is then just the difference, the revenue minus the cost. Notice that cost and revenue are positive, but profit could be positive, negative, or zero. Positive profit we would call a gain, and a negative profit would be called a loss. Sometimes when they say show a profit, that means have a positive profit, a gain. So which one of these is cost and which one's revenue? Well, a little bit of thinking shows that both of these should be increasing functions. If you increase the quantity you make, you're going to increase the cost, your total cost of making the total number of items. And if you increase the number of items you make, you're going to sell more, and that should increase your revenue. So notice these are both increasing functions. But the giveaway of which one's profit and revenue is the origin. The origin will always be on a revenue function, because if you don't make any items, you can't sell them, and if you don't sell any, your revenue is zero. Nobody's going to be just giving you money for doing nothing at all. So the revenue function always starts at the origin. Now the cost function typically starts not at the origin, but at some positive value, and that y-intercept there, that y value, is what are called your fixed costs. So fixed costs include things like any research and development that you do ahead of time, anything that doesn't depend on how many items you make. So if you have a certain amount of people that are on salary and it doesn't matter how many items they make, that could be a part of your fixed costs. If you have maybe buying your building or buying your initial purchase of your equipment, that could be a fixed cost. Most of your costs, however, are variable costs. Most of your utilities, for example, would be variable. The more items you make, or the more hours you run your factory, for example, the more electricity you're going to use. The more items you make, the more raw materials you have to buy, and so forth. And so those things are going to drive your costs up. So here we have something like this, and this might be a typical realistic kind of situation. Okay, so it might be that the revenue increases, but it's concave down because as you sell more and more of them, fewer and fewer people want them. Okay, and so to keep selling them, you may have to sell them at a smaller price. The cost might go up more sharply at first, kind of level out, and then it may increase more sharply later on as you start reaching the limits of how much you can make without maybe, say, buying a new machine or something, which might actually even cause a little discontinuity here. Okay, so explain the meaning of the words revenue and cost. We did that. What are the units on each axis? We talked about that. Which one's revenue and cost, and how do you know? We did that. What are the meaning of the y-intercepts? We talked about that. What's the relationship between profit, cost, and revenue? Profit is revenue minus cost. Okay, where is the profit negative and where is it positive? So profit is negative when cost is larger than revenue, it's positive when revenue is larger than cost. So let's see, revenue is blue. So when the blue is below the red, like over here at the beginning, we have a negative profit. Then we have positive profit for a while here where the blue is above the red. And then over here we have negative profit. This part of the graph way over here is a very unrealistic situation because no company is really going to go to this point over here to where they drive the company in the ground, because they're making, what's basically happening here is they're making items and most of them are sitting on the shelf. They're not selling them. If you're going over here where you have a negative profit, you probably deserve to go bankrupt because you're not very smart at all. These two places where it crosses here, where the profit or the cost and revenue are equal to each other, or when the profit is zero, those are called the break-even points. But this one over here really, again, would never really be reached. So this first one is really the break-even point. How can we graph the profit now? Remember, the profit is the vertical distance here. So this vertical distance for this, how far this blue one is above this red one, if we measured this little line segment right here, and then went that far above the axis, which it's, what is it? It's about it's a little over 2.5 of these little markings. So somewhere in here would be where the revenue would be the profit, right there. And of course, right over here where they cross, the profit would hit zero. Now over here where the red's above the blue, that vertical distance will be how far we're down here. For example, it starts at the opposite of the fixed cost, or the y-intercept for the profit. So let's go ahead and graph the profit function. Somewhere I have to graph the profit function. There it is. There's the profit function. So it starts down here, the same distance that the red one is above the origin. That's how far this starts below. Comes up, hits zero right here where the two cross. Then it goes up, and at some point it maxes out, and then comes back down. Again, any company that's way over here on the right side of this probably deserves to go bankrupt, because that's just stupid. But what you're looking for is the maximum profit here. So it's the maximum distance between these two curves. So how do you find the maximum distance between the two curves? How do you maximize a curve? So if you want to maximize the green curve, the profit curve, you want to find its derivative and set it equal to zero. But notice that if you take the derivative, if P of x equals R of x minus C of x, P prime of x is R prime of x minus C prime of x by the sum rule. So basically what we're saying is, or rephrasing with the words that we use in business a lot, we use the word marginal for profit, marginal for derivative when we're talking about many things in business. So we would say this third line here says P prime of x equals R prime of x minus C prime of x, or rephrasing, the marginal profit equals marginal revenue minus marginal cost. Now when is the profit maximized? When the P prime is zero. Well, so if you look at that, that's going to be when C prime equals R prime. So the profit is maximized when the marginal cost equals the marginal revenue. Okay? So remember, the marginal cost is approximately the additional cost for making one additional item. And the marginal revenue is approximately the additional revenue for making one additional item. So if you look over here, let's say we're over here at 50, okay, those slopes there, right here at 50, is just barely positive there, and more positive up here, bigger positive here. Those slopes of the tangent lines, or slopes of the curves, are the marginal revenue and the marginal cost, respectively. Okay, so notice that they're pointed so that those two tangent lines would intersect to the left of that point. So if you move back to the left, the two curves are getting closer together. Okay, whereas if you move to the right, the two curves are getting further apart. So we're not at the maximum yet. We can move further to the right. Now let's look over here at another point. Let's say at 80. At 80, the two tangent lines, can you kind of visualize them? They would intersect over here to the right. So moving to the right of 80 would decrease our profit, but moving to the left of 80 would increase our profit. Where is that profit going to be maximized? It's when the derivative is 0, the horizontal tangent line to the profit function. But what about the tangent lines here? Well, the revenue and cost functions would have tangent lines which are parallel. Okay? So the parallel tangent lines would indicate that, if the lines were pointing toward each other to the right, we could get it bigger by going to the left. If they were pointing towards each other to the left, we get better by going to the right. But if they're parallel, now we're at a local extremum, particularly a maximum here. Okay. And again, when does that happen? When making one more item costs the same as you would get for selling that one more item. If making one more item costs more than you would get by selling that item, you should be able to increase profit by making one fewer items. Okay, one fewer item. But if the additional cost for making one item is less than the additional revenue, you'll make more by going up. So if marginal revenue is more than marginal cost, make one more item, you can improve your profit. If marginal revenue is less than marginal cost, making one less item should improve your profit. When is it maximized? Exactly when the marginal profit and marginal cost are the same. And in general, this works for finding not just revenue and cost, but if we have two functions and we want to maximize the distance between those two functions, we're looking at where the derivatives of the two functions are equal to each other.